We're going to talk about the fundamental theorem of calculus, and it's sometimes abbreviated FTC. It sounds really, really important and really, really hard, but it isn't. The fundamental theorem of calculus is a way that we can evaluate integrals with just having to do it geometrically. And especially like if you have a parabola or some kind of other kind of curve, we don't want to estimate it with limits and with midpoint sums and Riemann sums and all those other things. We really just want to be able to find it exactly. So this is what the fundamental theorem of calculus says. If you have the integral from a to b of f prime of x, which is the derivative, that's normally what it looks like, that's called a definite integral, then it would equal the original equation, the antiderivative, evaluated at b, minus the same thing evaluated at a. And some of you realized that in the work that we were doing, that you could just find the original equation and evaluate it at b and at a. But that is the process that you'll use. So you find the antiderivative, you evaluate it at b and a, and then you subtract. And then what that gives you is the area from a to b of the derivative or whatever equation is that they give you. So let's talk about it here. You start off by finding the antiderivative. So here you'll use your power rule, x to the third over 3. And then you find the antiderivative of 3, which would be just 3x. And then you evaluate those two numbers at 1 and 2. So you plug in a 2 into the equation. 2 to the third is 8, so we have 8 thirds minus 6. And then we subtract and we plug 1 into the equation, so you've got 1 third minus 3. So you're just then going to figure out what that equals. 8 thirds minus 6 minus 1 third minus 3, and you get negative 2 thirds. How can that be negative, you say? Well, if you graph x squared minus 3, you'll find out that part of that graph is below the x-axis, and if you are trying to find the area from 1 to 2, you're probably finding some below the x-axis parts and some above, depending on the way that that graph looks. Okay, let's do another one. So the first thing we'll do is we'll find the antiderivative here. I'm going to rewrite that as 3x to the 1/2, and I'm going to think about, okay, how do I use the power rule here? I add 1 to the power, which would be x to the 3/2. Then I multiply the 3 times and flip the 3/2, so I have a 2 thirds. So really we have 2x to the 3/2, and we're going to evaluate that at 1 and 4. So then I plug in a 4, and then I plug in a 1. Alright, 4 to the 3/2, in case you were wondering, that means the square root of 4 cubed. Well, the square root of 4 is 2, 2 cubed is 8, and then so we have 8 times 2, which is 16. And then when we subtract 1 to the 3/2, 1 to any power is just 1, subtract that 2, so you get 14. Okay, one more, like this. Let's say that we want to find this one. Let's find the antiderivative. Okay, the antiderivative of sine would be negative cosine, because when I take the derivative of negative cosine of x, I get positive sine. And then I want to evaluate it at 0 and pi over 2. So plug in pi over 2 minus negative cosine, so that makes a positive, and plug in 0. If you remember, at pi over 2, that's 90, so that's up there at 0, 1. Cosine is the x value, so that's just 0. And then cosine of 0 is 1, because the x value is 1, and so we get 1 for that equation. Alright, so what if instead of just giving me the integral, it says find the area of this region and here's the bounds? Well, first thing I want to do is I want to graph that equation. 2x squared minus 3x plus 2. And I get a graph kind of like this. Okay, so it says it wants me to use the x-axis as a bound, meaning don't go below the x-axis. It wants me to use x equals 0 as a bound, and x equals 2 as a bound. So it's asking me to find this area here. So I know this is 2, and I know this is 0. And I could find those y values if I need to, but I really don't have to because I know that the area here would be the integral from 0 to 2 of 2x squared minus 3x plus 2. So then, after I figure out how to set it up based on the graph, if part of it would have been below the x-axis, you would have to make a negative to actually find the area. But all this was above, so that was nice. So I need to find the antiderivative, so we would have 2/3 x to the third minus 3/2 x squared plus 2x, and we want to evaluate that at 0 and 2. Plug in our 2 there, so we will get 8 times 2/3, so 16/3. Plug in 2 there, so that's 3/2 times 4, which comes out to be 6. Plug in 2 there, and we get 4. And then we want to plug in 0, well, you get 0 for that part of it. So then we have 16/3 minus 6 plus 4. 3 1/3 or 10/3. And that would be the area of that shaded region. One more thing that you can do with areas is you can find the average value. It's kind of like if we were using velocity and acceleration. If we wanted to figure out our distance, well, we talked about how we could do that, but let's say that we wanted to figure out our average speed over a certain time. Well, you would find the distance that you traveled, and you would figure out how much time that you went, and you would divide the two. So the average value formula is basically saying find the distance and then divide by the time. And so here's the formula for that. It's 1 over b minus a. B minus a is the time because that's like the seconds. Integral from a to b of f of x, because the integral from a to b of f of x is basically finding the distance. A lot of times that f of x, it might be f prime of x, but that's just the symbols that they use. But the 1 over b minus a is like saying if you're going from 30 to 60 seconds, the 30 and the 60 would be a to b. So you're dividing the distance by the time. Alright, so let's say that we want to find the average value of f of x equals 3x squared minus 2x from 1 to 4. So we're going to do 1 over b minus a, 4 minus 1, and the integral from 1 to 4, and then of 3x squared minus 2x. So we're going to find the antiderivative here. I know this is a third, and we'll worry about that at the end. But the antiderivative of 3x squared, I'm going to add 1 to that, so that'll be x to the third. Divide by the 3, so the 3's go away. Add 1 to 2x, so that would be x squared. Divide by the 2's. And then evaluate it from 1 to 4. I'm just going to multiply by a third, but plug in the 4. 4 to the third would be 64. 4 squared is 16, and then subtract a third times plugging in a 1. You would get 0. 64 minus 16 is 48. Divided by 3 is then 16. And that's the average value of that equation over that period of time.